Hello guys, welcome to today's tutorial. We'll be treating probability. So get your calculators ready with your writing materials. We'll be right back. Welcome back. Now today we'll be talking about dependent variable events and independent events. Now dependent events are two events are said to be dependent if the occurrence of event A does affect the occurrence of event B. That is to say, if the selection of A, if event A affects what will happen in event B, then B is dependent on A. Example is picking a ball from a basket or a bag or a box without replacing. That is to say, let's say we have 5 balls in our basket. If we choose the first ball without replacing it back, that means our second choice has been reduced, right? So the choice of A, the first choice, is affecting the second choice. Alright, that is what dependent events are. Now, for independent events, which are opposite of dependent, is simply talking about when the outcome of event A does not affect event B. Alright, that is for independent event. The probability of A happening does not affect the probability of B happening. The example is like tossing a coin and a die at the same time. Looking at our multiplication law, it says if two events are independent, then the probability of them occurring is probability of A times probability of B. Alright, now we'll also look at examples that handle both independent and dependent events. If you've watched up to this moment, please like, subscribe, and click on the notification button to get updated whenever we post new videos. And also do well to go to our Facebook page, to follow us on our Facebook page. Our first question says, what is the probability of choosing the delegation of 2 persons, 1 male and 1 female, from a staff list of 25 males and 35 females? Now, if we look at this question critically, we understand that since we are choosing a delegation of 2 people, when one person is selected, he can't be put back into the list for another selection. So we are dealing with a dependent event here, that where event A affects the occurrence of event B. Now, in order to calculate this, let's say selection of male, probability of male will become event A, and probability of female will become event B. Now, for us to calculate this, the probability of this, we are going to have probability of male times probability of female plus probability of female times probability of male. Now, this is saying the probability of male being chosen first times the probability of female being chosen second plus the probability of a female being chosen first times the probability of a male being chosen second, since this say in any particular order. Now, what's our probability of male? If we add up 35 plus this, we are having 60 staff. So this becomes 25 over 60, and this becomes 35 over 60. Okay, now if we reduce this to its lowest term, or we can leave it like that for easier calculation, this becomes 25, since our male is coming first, 25 over 60 times, now the females, if one male is removed from here, the total number at the second choice won't be 60 anymore, but 59. Alright, so this becomes 35 over 59 plus, if a female is chosen first, that becomes 35 over 60 plus times a male chosen second will become 25 over 59. Alright, now at this, we can now cancel out. 5 here will give us 5. 5 here will give us 12. Alright, so we are having 35 times 5 all over 12 times 59 plus 17, 5 here, 5, 5 here, 12. 35 times 5 all over 12 times 59. So if we do 35 times 5, 35 times 5 will give us 175 all over 12 times 59 will give us 708 plus 175 over 708. So if we add this up, we are going to have 708 as our LCM all over 175 plus 175. That is 350. Okay, now the next thing is, can we break it down? If we can break this further down to its lowest term, what is it going to be? We can use 2. 2 into 350 will give us 175 all over 2 into 708, 2 into 7, 3, into 10, 5, into 8, 4. So it will give us 175 over 354 as our answer. One bag contains 6 red balls and 4 blue balls. Another bag contains 5 red balls and 3 blue balls. If a ball is chosen from each bag at random, what is the probability that both are red? Now, if we look at this question, we can see that choosing a ball from bag A does not affect the choice of bag B. Alright, so we can simply say that this type of events are independent events, okay, where the choice of event A does not affect the probability of event B. Alright, now if our first bag is event A, okay, now probability of red will become 6 plus 4 will give us 10. So this becomes 6 over 10, and probability of blue in the first bag will become 4 over 10. Now, in our second bag, event B, the probability of red there is 3 plus 5 is 8, so that will become 5 over 8, and probability of blue in the second bag will be 3 over 8. Okay, now to our question that says find the probability that both are red. Now, if both are going to be red, that means it will become probability of red will become probability of red in A times probability of red in B, which is going to give us 6 over 10 times 5 over 8. Okay, we can now cancel 1, 2, 2 here, 1, 2 here, 3, which will give us 3 over 8. So the probability that both are red will be 3 over 8.